Good evening, everybody. Today we'll be talking about a topic about fundamentals of fluid flow. I assume everyone has a little bit of background about it, but we're just going to be talking about the fundamentals of fluid flow. Just going to write that down here. Fluid flow fundamentals. Okay. And majorly what we're going to be talking about is something some of you might have heard of. It's the Bernoulli equation. Okay. Bernoulli equation. All right. The Bernoulli equation gives an approximate relation between pressure, velocity, and elevation. We note that as H. So pressure, velocity, and the elevation in height in various regions of, so it gives you the approximate relation between these three parameters in various regions of a steady incompressible flow. So note that it has to be steady, okay? Has to be incompressible flow, sorry about my handwriting, okay, where the net frictional forces are determined negligible, okay? Now, the Bernoulli equation approximately is typically useful in flow regions outside of the boundary layer, right? So the Bernoulli equation pretty much gives an approximate equation that is valid only in invisible regions. Invisible regions of flow where there's no viscous forces, all right? So for example, if I have a streamlined body over here, right, and streamlines, going around that, okay, in this regions over here, Bernoulli equation is not valid. Oh, oops. It's not valid, okay? It's not considered valid. However, in these regions, it is considered as valid. All right? Now, it pretty much, I'm not going to go through the, how to develop the equation, for example, but it pretty much goes through using the acceleration of a fluid particle and, gets the Bernoulli equation on the unsteady flow. However, I'm going to be discussing about the limitations. I'm just going to clear this out. I'm going to be discussing about the limitations of the Bernoulli flow, right? So, it has to be steady flow. It has to be incompressible. There are other limitations for the Bernoulli as well. One we've already spoken about is it has to be steady. It has to be incompressible. Okay? And then it has to be a frictionless flow as well. Okay? It has to be considered as friction being negligible. Okay? Another thing is if friction is deemed negligible, that means you also have to assume there's no heat transfer. Present within the body. And as I drew earlier in the streamline over there to show where Bernoulli equation is valid, right? It's valid over there. The flow as well, another limitation. Another limitation is that the flow has to flow along the streamline. Now, I'm assuming everyone knows what a streamline is, the streak line, and things of that nature. Also, lastly, there has to be an assumption that there's no shaft work, right? Those include, things like pumps, turbines, and things like that, right? Instead of using the Bernoulli equation, the energy equation is what would be used.